Welcome back. Today's question is Coco eating banana. It is one of the most important frequently asked DSA interview question. By the end of this video, you will understand the intuition behind it, how it works, and the most optimal solution in C++. First, we understand how the problem statement. First, I should read the statement. Coco loves to eat bananas. There are n piles of banana, and ith piles has piles I banana. The guard have gone and will come back in H hours. Coco decide her banana per hour eating speed of k. Each hour she chooses some pile of banana and eats k bananas from that pile. If the pile has less than k bananas, she eat all of them instead and will not eat any more bananas during this hour. Coco likes to eat slowly, but still want to finish eating all the bananas before guards return. Return the minimum integer case such that she can eat all the bananas within h hours. So in this question, it is given that we are given an array in which element represent the size of a pile. Coco has to decide the speed in which the speed should be the minimum. We have to minimize the speed and such that she can eat all the bananas in all the piles within the h hour limit which is given in the question. So for this, we can see that we have to decide the range in which the we have of the speed of the cocoa. The range can be started from 1, and what will be the maximum range? Maximum maximum eating speed should be the largest maximum element in the array. So, as in example 1, piles 3, 6, 7, 11. The smallest speed is 1 and the maximum speed is 11. So, for the brute force is quite straightforward, eh, in which we can try all the speed, but it is very lengthy approach. Such if we see that if the array have 1 billion, the maximum number is 1 billion, then this approach can have the time limit expectation. So what should we do? The optimized solution that comes to my mind is binary search, as we have to find uh, in the max monotonic increasing range, we have to find a most optimal range. So for that, we will for that we will take a mid and check if the mid i- if the mid the speed mid which is chosen in this speed can Coco eat all the bananas, and also if this speed is less than h, if yes, then we can go the lower part because uh, it is one of the viable solution, but we want to find the minimum, so we will go to the less number. Or if it is not checked, means all the number which is less than this mid can also not complete the condition. So in this we have to go higher for higher number. And for checking the speed, we will first create a function check in which we will iterate to hold the array. If the eating speed is equal to the piles of banana, then we will start a count pointer where we increase it by 1. If it is divisible by the eating speed, means if we have chosen the speed 4 and there is banana 8, then Coco will take the 2 hours time to complete it. So we will uh, we will add the division of pile of ith banana by the mid speed we have chosen. Or if it is not divisible, then we will simply add by 1. It means that if there are 9 bananas and speed chosen is 4, then the time taken is 2 hour plus 1, as Coco cannot leave as it is given in the question, she eat all of them and will not eat any more bananas during this hour. Means uh, when she have eaten 8 bananas, then she will eat the ninth one and wait for an hour, then goes for the next. In this way, we can solve this question. So let's start by coding it. So as here, we will first create integer n, which is the size of the files array. Then we'll create a maximum. As we have discussed in the previous approach, that we will have to create a range which is from 1 to the maximum element. So first we'll find the maximum element in the whole array by iterating through it. And for this time complexity will be O of n. Then we will create a range for low equals to 1 and high equals to maximum. The low and high describe the lowest and the highest element in that range. Then we will do a binary search if we will we will create mid, which will be given by this formula, and if the mid speed which is taken as mid complete the all the prior qualities, then we will assign the speed to mid, and we will move to the left part of the array, so that we can see that there can be more element that can justify the condition and will be less than the mid which is taken for now, or else we will move to the right side of the and check if is any element which will prove the condition. And for the check function, we will create we will create a count integer which will take the count of the bananas, and if count of the r's, and if count of the r is greater than, then we will return false, or else we will return true, for which we will first iterate through the whole array and check if mid is greater than equals to piles, then we will count plus plus. If piles is greater than mid but it is divisible by mid wholly, then we will just add piles divided by mid into the count, or else in else condition it means piles of I is greater than mid but it is not divisible by mid, then we will just divide piles by mid and add 1. In this we can adjust the count and check if it is the greater than h or less than h. If it is greater than h, then we will return false, otherwise we will return true. In this way we can iterate through whole array and check when the speed is the minimum. And we will run the question. Mhm. As you can see that this run very properly, and therefore time space complexity is O of 1, and the time complexity for this time complexity for this is O of n, and for binary search is O of n log n. So the whole time complexity is O of n log n, and the space complexity is O of 1. Thank you.